Hello everyone. Today I will be talking about the Gaussian mixer model, which is under the unsupervised cluster of machine learning. Before going directly into the topic, I would like to give a little preview, as we know that Gaussian mixture model comes under machine learning. So, what is machine learning? Machine learning is a subfield of artificial intelligence AI that focuses on developing algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed. The computer is trained on a large dataset, using statistical and computational methods, to learn patterns and relationships within the data. This process involves developing a mathematical model that can make predictions or decisions based on new input data. And under machine learning, we have different techniques of machine learning, which are as follows: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. So now let me give a brief explanation of the above techniques. Supervised learning are those that have features, dataset and goal. Datasets are in which labeled input data is accompanied by the corresponding output or target variable. And the goal is to learn a mapping function that can accurately predict the output variable for new input data. And in unsupervised learning are those in which the dataset is unlabeled, means that the input data has no corresponding output variable. And goals are to discover hidden patterns or structures in the data, such as clustering similar data points together. In semi-supervised learning, it combines both supervised and unsupervised learning techniques, in which dataset is a partially labeled dataset, meaning some of the data points have corresponding output variables, and some do not. The goal is to discover hidden patterns or structures in the data, such as clustering similar data points together. Reinforcement learning is a type of machine learning where the algorithm learns by interacting with an environment. How learning takes place. It takes receiving feedback in the form of rewards or penalties. The goal is to learn a policy that maximizes the cumulative reward over time. In here we can see the types of unsupervised learning, which are as follows: clustering, dimensionality reduction, association rule learning, anomaly detection, and generative models. In unsupervised clustering, it involves grouping similar data points together into clusters, without the use of any labels or prior information about the data. Useful for discovering hidden patterns and structures in the data. The idea behind unsupervised clustering is to group similar data points together and separate dissimilar ones. Examples are k-mean, hierarchical, spectral, etc. In Gaussian mixture model, GMM. A Gaussian mixture model is a type of clustering that assumes that the data point is generated from a mixture of Gaussian distributions with unknown parameters, each with a different mean and covariance matrix. The GMM algorithm works by estimating the parameters of the Gaussian distributions that generate the data. These parameters include the means, covariances, and mixing coefficients, weights, which specify the probability of each distribution in the mixture. Now about the working of GMM. First, we will see training process. 1. Initialization. The algorithm starts by initializing the parameters of the Gaussian distributions, including the means, covariances, and mixing coefficients, weights. 2. Expectation step, E step. In this step, the algorithm computes the probability of each data point belonging to each of the Gaussian distributions. It does this by using the current estimates of the parameters to calculate the probability density function, PDF, of each Gaussian distribution for each data point. The probability of each data point belonging to each Gaussian distribution is then computed by normalizing these PDF values. 3. Maximization step, M step. In this step, the algorithm updates the estimates of the parameters based on the probabilities computed in the E step. Specifically, it updates the means, covariances, and mixing coefficients of the Gaussian distributions to maximize the log likelihood of the data given the model parameters. 4. Convergence check. The algorithm checks whether the parameters have converged, by computing the change in log likelihood between the current and previous iterations. If the change is below a certain threshold, the algorithm stops and outputs the final estimates of the parameters. 5. Cluster assignment. Once the GMM has been trained, it can be used to assign new data points to clusters by computing the probability of each data point belonging to each of the Gaussian distributions and assigning it to the cluster with the highest probability. Overall, the GMM algorithm iteratively estimates the parameters of a mixture of Gaussian distributions that best fit the data and uses these parameters to cluster the data. It is a powerful technique for modeling data with complex distributions and identifying clusters with different shapes and sizes. The advantages of GMM are: flexibility, fit a wide range of complex data distributions. Soft clustering, it can assign data points to more than one cluster with different probabilities. Number of clusters, GMM can automatically determine the optimal number of clusters. Can handle data with different shapes and sizes. Robustness to noise. Provides uncertainty estimates. Disadvantages. Sensitivity to initialization, different initializations can lead to different results. Computational complexity, computationally expensive for large datasets. Number of clusters, while GMM can automatically determine the optimal number of clusters based on the data, it can still be challenging to interpret the results and determine the appropriate number of clusters. Assumes independence between features, may not always be true in real-world datasets. Limited applicability to non-Gaussian distributions. Applicability of GMM. GMMs have various applications in machine learning, such as clustering and segmentation of data, image and speech recognition, anomaly detection and fraud detection, modeling and predicting financial time series data. Applicability of GMM in different fields. Computer vision can be used for image segmentation. Speech recognition, GMM can be used for speaker identification, where it can cluster speech features to identify the speaker. Finance, for portfolio optimization, where it can cluster financial data to identify different market regimes and adjust the portfolio accordingly. Marketing for customer segmentation, where it can cluster customers based on their behavior or preferences to improve marketing strategies. Bioinformatics, for gene expression analysis, where it can cluster genes or samples based on their expression patterns to identify functional groups. Natural language processing, for topic modeling, where it can cluster documents based on their content to identify different topics. So in conclusion, we can say that Gaussian mixture models are a powerful tool for modeling complex distributions and discovering underlying patterns in data. By understanding how GMMs work and their advantages and limitations, you can apply them effectively to various machine learning problems and get an outstanding results from it. Thank you.